if you have A multiplied by B, the answer is 0. Either A is equal to 0 or B is equal to 0, because A times B, which is a 0, gives you a 0. Or B times an A, which is a 0, still gives you a 0. The other case is that 0 times 0 is equal to 0. That is, they are both equal to 0. One can equal to 0 and the other one equals 0. They can be both equal to 0. But now, look at this equation here, x squared minus 5x plus 6 is equal to 0. We need to factorize. Get the first term here, and x multiplied by x are the factors of x squared. If you multiply these two, you get this. And then this here is 3 multiplied by 2, which gives us 6. It's going to be negative multiplied by negative. These two here will give us a 6. But if you multiply an x by a negative 2, you get negative 2x. Multiply x by negative 3, you get negative 3x. That gives you negative 5x, which is that. Therefore, you can say that x minus 3 into x minus 2 is equal to 0. That is x minus 3 is equal to 0. Or x minus 2 is equal to 0. Therefore, x will equal to 2 here. X will equal to 3. But now, I hope you realize the effect of that. We should get up there is either B is a 0 or is either a 0 or they are both equal to 0. Let's look at the inequality given by that quadratic expression. X squared minus 5x plus 6 is equal to 0. It's greater than 0. This is an equality. The other one was an equation. So the factors you know here is going to be x minus 3 into x minus 2. Now, remember, we said A multiplied by B is greater than 0. That's the key. This one will be A, and that will be B. Here, if you multiply two numbers and you get a positive number, right? Number line here, and that's 1 here, 2, this one, minus 2. If it's greater than 0, it means it's positive. If it's less than 0, it means it's negative. Now, here is either A is positive and B is also positive, because a positive multiplied by a positive will give you a positive. Or, now look at that. This is or is here. Here we have and. So, or the second case could be that your A is negative and B is also negative, because a negative multiplied by a negative will give you a positive. Let's have a look at the first case. Let's this called case 1. Call that case 2. In case 1 here, we have x minus 3 is positive and x minus 2 is also positive. That's this scenario here. Now, you have x, which is greater than 3 here. At the same time, the very x is greater than 2. Now, if x is more than 2, let's look at something of interest here. If x is more than 2, x can be equal to 2.25, which is a quarter, 2.5, which is a half, or 2.75 to 3/4, or it can be 2.99. Now, all these numbers here are greater than 2, but all these numbers here are less than 3. So, if you come here, look at this side here, you see any numbers more than 3, it will be 3.1, 3.25, 3.5, 3.75. I hope we agree that all these numbers here are bigger than 2. Therefore, we are going to take this as our solution for this case. Why? Because x is more than 2 is included in x is greater than 3, as I've just shown. Let's look at the second case. Case 2. Case 2, we have when all these numbers are negative. A is negative, which means x minus 3 is less than 0, which makes it positive, and at the same time, x minus 2 is also negative. Therefore, x is less than 2. This side, x is less than 3. Now, any number that is less than a 2 is also less than a 3. Therefore, we are going to choose this scenario here. So, our solution will be x is greater than 3 and x is less than 2. If you want to represent this on your graph, there will be 0 here, minus 1, 1 here, 2 there, 3 there. On your graph, x is greater than 2 the very x is less than 3. Therefore, your solution is here. Your solution is here. Now, I want us to illustrate the above case by drawing a parabola, because this here is quadratic. Now, we have x squared minus 5x plus 6 is equal to 0. So the factors here, x is equal to 3, or x is equal to 2. If we have to draw this quadratic on a Cartesian plane, we have something like that. And we will have the y-intercept will be 6 there. And then we have 1 here, 2 there, 3 there, 4. And we agree that x will, the roots will be 2 and 3. Now, the graph can come this way. The graph can come this way. The graph can come that way. The graph can come this way. Now, compare this with x squared minus 5x plus 6 is greater than 0, which means it's positive. Now, I hope you agree that anything between 2 and 3, the graph is negative there, because y is positive there, y is negative there, x is negative there, x is positive there. But anything, and that's our 0, 1, 2, minus 1, minus 2, anything greater than 3, the graph is positive, f of x is positive. Anything less than 2, the graph is positive, because at x equal to 2, the graph is 0. At x equal to 2, y is 0. Therefore, as the x-intercept, anything you can see that between anything greater than 2 and anything greater than 3, the graph is positive. Let's look at this one here. Now, here we had x is greater than 3, which means we are supposed to move. There's a mistake here. We're supposed to say x is 3, go this way. That's that. X is less than, we go this way. Now this agrees with our parabola here. Sorry for that mistake. That's what we have. Now, the parabola is not part of the solution. The solution only lies here. You can take any number, you can take 4, put 4 here, that will be positive. You can take any number, 0. If you put 0 here, you have 6. 6 is greater than 0, which is true, it's positive. Number there, it's a solution. Now, I want us to have a look at the very equation, but reversed in terms of a sign. You can have the very equation x squared minus 5x plus a 6, let's say is less than or equal to 0. Well, let's just say it's less than a 0. The previous one was greater, now it's less than. But you know the factors here are x multiplied by x, factors here 3 and 2, negative 2, negative 3. Now, we have x minus a 3 into x minus a 2 is negative. Now, when we multiply a multiplied by d and it's negative, is either a is positive while d is negative, because positive multiplied by negative is negative, which is less than 0. Or the second case will be the very a can be negative and d being positive. Negative multiplied by positive is a negative. So we're going to look at this case and that case. Let's call this case 1 once more. We'll call this case 2. With case 1, we said the first one is positive, so it's going to be x minus 3 is positive, and x minus 2 is negative. Here we have x is greater than 3, and x is greater than 2. Anything that is more than 3 is, of course, more than 2. Therefore, 2 is included in the solution. We'll take that. Because if you take this one, we can write 2.5. 2.5 is greater than 2, but 2.5 is not more than 3. Therefore, 3, any number 3.1 is greater than 2. So we take this one here. Let's look at case 2. Case 2, the first one was negative, which means this would be negative. So x minus 3 will be negative, and x minus 2 will be positive. So x is less than a 3, and x is greater than a 2. Now, here, you'll agree that a number if you draw a diagram here, 0, 1, 2, 3, see x is less than a 3, and x is greater than a 2, this is a mistake here. It's a mistake here. That it's supposed to have written x is less than this, less than here. So if you look at that and look at the first one, say x is more than 3, from here it goes there. At the same time, x is less than 2, which is impossible. This is impossible. x cannot be from this graph here 0 1 2 3. X cannot be more than 3, which is about 4 5 6 7. At the same time, x is less than 2, which is minus 1 1 0. This doesn't make sense because of that. Now, your solution will be that you can choose any number here. But now, it's because um, it is less than, it means 3 is not included and 2 is also not included. So the proper presentation on the number line should be this. Three is not included, 2 is not included. If we had x is greater than or equal to, then 1 2 3 there. This will be that 2 is included because of the equal sign. That will be that. That's how we represent that. And in set builder notation, this will be 2 and 3 there. This one here will be 2 and infinity here. That is included, that doesn't include. 2 is included here, that's what it says. Let's have a look at the last one here. The last one here. The last one goes like x squared plus 3x minus 5 is equal to 0. I hope you appreciate that we go to the first one and the last one. It will be x and x. 5, it will be 5 and 1 or 5 and 1 then. But if I add that, I will get a 6. If I separate, I'll get a 4, which is not that. So basically, if you go back to the nature of the roots, we have that discriminant, which is b squared minus 4ac. Our b is a 3 there, it's going to be 3 squared. Our a is a 1 there. And our c is a minus 5. This is 9. Negative and negative is positive. Plus a 20. That gives us 29. I hope you can see that this is not a perfect square. Like 9, 16, 25, 100. These are perfect squares. This is a perfect square. So the roots are irrational. So we can use a quadratic formula to get the roots, which will be x is equal to negative b plus or minus b squared minus 4ac all over 2a. That our b is a 3 there. Our a is a 1, our b is a 3. Our C is a 5. Therefore, that's going to be -3 plus or minus the square root of b squared minus 4ac gives us that. The square root of 29 all over 2a is 2 multiplied by 1, which is 2. Now, if you punch your calculator, you have -3 plus the root of 29 all over 2, or the other root will be -3, -29 over 2. Now, if you punch your calculator, you will have 4.2 and 1.2. Therefore, you have 4.2 and 1.2. That's what you have. So it means equation should be, the equation is going to be x. The other one is minus. This one is a minus here. This one is going to be a plus. So we have x plus 4 over 2 into x minus 1.2 is equal to 0 for this one here. But on the top one is going to be less than equal to that. That will be less than 0 there. Now, so the negative was supposed to have been here. Negative that. And the positive is supposed to be there. This one and that. So that's what you have. Now, this forms the critical point. These are your critical point where x is those two irrational roots. Now, if you have that, you can go back to the previous equation here and apply that knowledge and get the value of x, and your graph will look like 1.2 here, -4.2 there, 0 there. Now, your graph presentation should be of this nature. That will be the presentation of that solution. I hope you got that.